There we go. All right, I'm Beth Courtwright. I'm the operations manager here at Pajarito Environmental Education Center, or PEAC, in Los Alamos, New Mexico, and I'll be the moderator for tonight's talk. Just a few logistics for tonight before we get started. Our presenter is going to be taking questions via Zoom chat and from our in-person audience. For those of you watching at home, you can find the chat feature in the menu bar on your Zoom, and you can type your questions to the PEAC moderator in the chat window anytime during the talk, and then I'll read them at the end for the Q&A session. Please remember that not everyone here in the room with us has a microphone, so if there's a delay when we're listening to a question from the live audience, don't worry. We'll be back on in just a second to repeat the question for everyone to hear. After the talk, you'll receive a short evaluation in your email. Please do take a moment to fill that out. It really helps us to improve our future programs. Okay, a bit about tonight's presenter. As a hydrologic technician, Jaz works with montane climate and weather monitoring for the purpose of water supply forecasting. He will discuss tonight how measurements of the mountain snowpack translate into data that guides decision making for water users throughout New Mexico, which is a hot topic. So Jaz, without further ado, I'll just thank you for joining us, and I'll turn it over to you and watch the chat for any questions.
Great. Thanks, Beth. Hello and welcome. This is a great opportunity to do a brief sound check for those on Zoom to make sure they can hear me on the microphone. Okay, so barring any complaints, I'm going to assume that I can be heard loud and clear. So thanks for those of you who have come in person and those who are tuned in online as well. My name is Jaz Ammon, and I'll be talking about the USDA Department of Agriculture Natural Resources Conservation Service Snow Survey Program. One theme that you will pick up throughout the night, if nothing else, is that the federal government loves abbreviations. So we've got lots of these abbreviations. So again, I'm Jaz, avid outdoors person. I love being out in the snow, but paradoxically, a lot of my field work actually takes place in the summertime. So I'll get into more of that further in the presentation. But I am a hydrologic technician, and I work for the Natural Resources Conservation Service based out of our state office down in Albuquerque. So I've traveled up here to Los Alamos for tonight, but also several times for our routine maintenance and other fieldwork tasks throughout the year. And I began this position actually in January of 2022, so I'm just about a year into this role here in New Mexico. So tonight I'll be talking about our snow survey program. I'll give you some background and context. I'll talk about what we measure, why we measure it, where we do those measurements, how we share those data, how one may access the NRCS climate data and our products, and how we use some of our data. And then we'll get into some of our current conditions in this local area at the end. Again, as Beth said, if questions come up throughout, please do put those in the chat and we'll try to get to most of the questions at the end. We have some time allotted for that, but I'm hoping for a little bit of audience participation as well. So I'll start off with a little bit of hydrologic trivia. Does anybody know what water year we are in right now? Okay, so I'm seeing a few head shakes. As a hydrologist and in the field of hydrology, we measure a water year which starts on October 1st and goes until September 30th of the following year. So given that, we are currently in the water year 2023. The previous water year would have ended at the end of September. The reason for that is, especially here in the Western United States and in North America, the bulk of our annual precipitation, the volume of water, actually comes during those winter months. So if we're doing calculations, it's easier for us to think that we could start and end during a pretty dry part of the year and then start calculating again until that driest point in the year, which is usually in September or October. Of course, in the desert Southwest, we have the monsoon, which is unpredictable and can throw off those calculations somewhat. But anyway, we're in water year 2023 right now. Second question would be, what major watershed basin includes the slopes and drainages around this town here of Los Alamos?
And I just want to say, if anyone has an answer that they want to share or try to answer Jaz's questions, you can type it into the chat, and I'll wave to them here in the room if we have some contributions from the people on Zoom.
Great, thanks. Any guesses here in the room? We're talking major watersheds. Some of these may be kind of obvious. There's a hint on the screen here as well. Yes, the Rio Grande is one. We also call this the Upper Rio Grande or the Rio Grande Chama watershed. And I'll show some maps. I'm a map nerd, so we'll have a lot of geographic visuals, and that'll come up right after this. And then the water that falls on these slopes and drainages, where would this water end up at the end of its freshwater cycle? Say it didn't evaporate and just stayed on the ground and flowed through the river system, where would that end up? We had an answer, which was the Gulf of Mexico. So we are on the eastern side of the Continental Divide. New Mexico spans both sides of the Continental Divide, and the Rio Grande flows over to the Gulf of Mexico. If we were on the other side of the Continental Divide, that water would go through generally the Colorado River system and end up in the Pacific Ocean. So I just like to place us in the context of where this water originates from, which is the atmosphere and our slopes and drainages here, and where it ends up, which would be one of the two oceans that border the country. So here's a question that's near and dear to my heart. Does anyone know where the closest Natural Resource Conservation Service SNOTEL site would be located? And again, I'll get to some maps and things, but I just want to, we got a hand in the back.
Sorry, Kelsey's on chat, and she guessed San Pedro Parks.
Okay, that's a great guess. I'll show you a map here in a second. Our closest site is called Camazon, and it's up on the Caldera Rim. So it's almost just directly upslope from Los Alamos. The Camazon Trail system will take you basically up there. It's in a saddle kind of between the Pajarito Resort, some of the taller peaks along the Caldera Rim. So I'll show that to you in an area map in a moment. So great guess. And then along with the snow telemetry sites, which are high elevation montane weather stations, we also maintain a small network, growing network of lower elevation weather stations. These are called the Soil Climate Analysis Network, another abbreviation, SCAN sites. And we have one of those fairly close to Los Alamos as well, which is covering a representative landscape that's very important for agricultural producers. Any guesses as to where that might be located? Yeah, Bandelier is a great guess. This one is at Alcalde, and I'll just go ahead and forward the map here to give away all of my answers. So as I mentioned, Los Alamos, just up slope. It's kind of hard to see the topography on the screen here in the room, but at about 9,500 feet, we have the Camazon SNOTEL site just upslope on the Caldera Rim. And then north of us along the Rio Grande Valley in the Espanola Valley is the Alcalde low elevation scan site at about 5,700-ish feet in elevation. So that lower elevation station is trying to measure a representative measurement for agricultural producers in the Espanola Valley. Alcalde is a agricultural research station owned by the New Mexico State University. So anyway, just to introduce you to kind of our general network, in this area, we also have an even higher elevation site on the north side of the Caldera Rim called Garita Peak. and that's really close to the feature on the landscape called Garita Peak. Across the valley, up above Santa Fe, on your way up to Ski Santa Fe, there's an even higher elevation Snowtel site at over 11,000 feet, almost 11,500 feet in elevation, kind of in the Aspen Vista area. That's our Santa Fe Snowtel site. So thanks for your participation in those kind of icebreaker questions and just putting us in the local context. So to answer that question about the major drainage basin that we are in, it's a tricky question because the white dot on the screen here is generally where Los Alamos is. You can see that there's a drainage boundary line right about almost exactly where Los Alamos is located. So we have the upper Rio Grande Basin, and we have kind of the central Rio Grande Basin. And actually that weather station up above us could be used to approximate forecasts on both sides of that drainage divide, because any water, snow or rain that falls on the inside of the caldera is going to go down San Antonio Creek and some of those other drainages down through the Jemez and to the Rio Grande below us. And any water that falls on this side of the caldera rim near Los Alamos is going to flow into the Rio Grande or the Chama closer to town here. So that would be included in the upper Rio Grande Basin. So administratively, I work for an entity out of the Federal Center in Denver. So we're the Colorado Data Collection Office, or DCO, another abbreviation. And we have several staff. As you'll see on the list here at the bottom, I'm the one person full-time dedicated to New Mexico within this program. I have a colleague named Travis who's over in Arizona who does the same thing. And then a network of hydrologists and hydrologic technicians in Denver who cover a wide region all across Colorado, New Mexico, all of Arizona, and parts of Wyoming. So what is the function of the NRCS Snow Survey and Water Supply Forecast Program? In the Western United States, snow equals water. So the majority of the surface water that we receive in New Mexico on an annual basis comes from spring snowmelt, and that's on a long-term basis. A year like this year where we had a weak snowpack, we had a La Nina winter last winter, and then a really heavy monsoon season, that's an outlier. But on average, over the years that we've been measuring, the majority of our surface water does come from snow. So the snow that you see on the landscape translates directly into stream flow, especially as you get farther north and especially as you get higher in elevation. So why does the New Natural Resources Conservation Service Snow Survey and Water Supply Forecast Program operate? We have several primary objectives here in this program. We do monitor the snowpack and other climatic conditions and provide data to end users. The Natural Resources Conservation Service, being a part of the USDA, our primary consumers, our clients or customers, are generally agricultural producers. Those are the primary people who are going to rely on our products that we produce. We do disseminate our data, forecasts, and products via the website, web services, some reports that I'll get into later, and other means as well. We issue monthly water supply forecasts for the river systems in the Western United States. So this program, while I work for the Colorado branch of this program, it covers all of the Western United States, including Alaska. So we are just one branch within that. I will publish a water supply outlook report that includes our monthly forecasts for every winter month. So we go generally from the first week of January until May here in New Mexico, and up in Colorado and Wyoming, other colder states, they'll issue a forecast and a water supply outlook report in June as well. We provide all sorts of products and summaries and reports, which I'll get into later. And then we do also serve as a technical resource for data users, so researchers, climatologists, forecasters, the National Weather Service, and other users will refer to our data and our specialists when they're creating their products. So a little bit of brief history. This program did start out with manual snow surveys, and I actually do continue to participate in this process. So we do physically go out onto the landscape and measure snow to ground truth our weather stations and provide additional data inputs for our forecast. But this program originally started in 1906 in California, and many of the sites that they measured on that first initial survey in 1906, over 100 years ago, they're still measuring those sites manually. And in many cases, they've also augmented or replaced some of those manual snow survey sites with automated snow telemetry stations. So these weather stations that I'll get into in more detail. A bunch of funding came in the 1930s to continue measuring snow and generate water supply forecasts. And in 1936, the first forecasts were recorded in Colorado using manual snow course measurements. I'm glad I don't have to use this antiquated equipment to get to my sites anymore these days. Quite a lot of work. But although I'll go back one, we do use this same, these are the actual snow sampling tubes that we do use on our manual snow surveys. So manual snow surveying, this is the winter fieldwork that I primarily take part in. If we don't have a network outage or some damage to an automated weather station, I won't go out into the areas where we measure the snow except for once a month at the end of the month to do these manual snow surveys. So we are trying to measure snow water equivalent. Another abbreviation, we do SWE, S-W-E. That is the amount of water that's actually held in frozen snow. So we also measure the density of the snowpack. Most of our courses are 5 or 10 points, like shown on this slide up here. They're predetermined locations that we revisit month after month, and we poke a hole in the snow and we weigh it. And some smarter engineers than myself have taken this snow sampling tube and it's actually calibrated in inches of water. So we punch that down into the snow, we pull it out and we weigh it, and that gives us a measurement in inches of water. So again, we measure these at the end of the month, and that helps to supplement the forecast that we produce at the beginning of the following month. So I'll go out at the end of December, and then we'll issue a forecast at the beginning of January. We'll continue that through our May Basin Outlook report here in New Mexico. So over the years, this labor-intensive process of actually going out and measuring snow courses and trying to keep all these points consistent over time has been gradually augmented and slowly replaced by automated methods. So we have the snow telemetry network as it exists today because of those original manual snow surveys and that long period of record of the data. But we've found that we can do continuous measurements and automatically update those into the internet and other data acquisition platforms without having to physically drive out to those locations, ski or snowshoe or snowmobile to that site and take a measurement, record it down, and then report it. This station can do a lot of those things itself. So in the 70s, that's when telemetry was added to some of these automated snow stations, weather stations, and that's what really began the snow telemetry network. In the late 70s, we continued to add more of those stations to the network all across the western United States, and I'll show a map of our region and where those are located in a moment. And then I have a question here. Does anybody know when the last SnowTel site was installed in New Mexico? So we began in the 70s with this program, and we've been installing new stations as time goes on. I don't expect you to know that, so I'll just go ahead and give away the answer. It was last year, 2022, prior to my arrival in the program. And if you didn't know when, you probably wouldn't know where, but does anybody have a guess where our newest station might be located? We're pretty proud of this one. We built an entire snow telemetry site, automated weather station on the Taos Pueblo land. So it was a cooperation between the United States Department of Agriculture, our program within the Natural Resources Conservation Service, and the Taos Pueblo, because it's on tribal land. So hopefully the data produced from that station will help with some of the oldest water rights that are held within the state of New Mexico, with them estimating water use in the highest parts of the watershed. This is not. No, I think this mountain in the background is a little bigger than ones we have here in New Mexico. But actually, you can see Wheeler Peak from the one in Taos. And we have more snowtail sites in Taos County than any other county in New Mexico. And we do have several high alpine and subalpine stations, but this one is not a picture. Some of these slides are recycled from my colleagues in Colorado. I think this picture is actually from Colorado, but it may be like a Mount Rainier in the background as well. Good question. Many of the sites do look very similar to that, though. So here's our network, the physical locations of where we measure alpine snow in the west, in the Colorado region. So as I said, we cover parts of Wyoming up there in the north, a whole bunch of a dense network throughout Colorado, many sites here in New Mexico, and then over in Arizona as well. So that comes to a total of 186 snowtail sites, 29 of which are here in New Mexico. We also have, in addition to the high alpine snowtail sites, we have 18 manual snow courses that we maintain here in New Mexico. And then we have 8 of these lower elevation soil climate analysis or SCAN network sites. Those will be the red dots on the map of New Mexico on the right. And then the light blue on the map on the right are our manual snow courses where we actually go out and poke holes in the snow and weigh it. So here in this immediate area around Los Alamos, here are the representation of the snowtail sites in our general vicinity. So we have a couple overlapping labels above Camazon there, but there is the Pajarito Peak one I mentioned. I have 2 on the western side of the Valles Caldera, so Vacas Locas and Señorita Divide. And these colors will become more important as we get into some of our products, but unfortunately the hues on the map don't match up with the key very well. But the red ones basically indicate less than 50% of our long-term median snow water equivalent, which is what this map is showing at these sites. So this data is being reported live, and I can access this on our interactive map. A couple of these sites you'll see X's on. That's because they're newer sites, and we don't have a median for this long-term range from 1991 to 2020. So yes, go ahead. So the question was, why have Señorita Divide and Vacas Locas so close together? I think part of the reasoning behind that was redundancy. Since we don't go out to that area and do manual snow course measurements, we can kind of catch any data variation or errors or anything like that by having redundant systems there. And I would imagine that they're also in slightly different drainage systems. So one may flow into a creek that actually goes further over toward like the San Juan River, and one might go up to the Chama. But they are very closely located. Generally, we do try to get wider spatial variation, so that's a great question. These ones were built a long time before I arrived here, so I actually don't know the answer to that question, but good question. And sorry? So the question is, for being so close together, why are the colors so different? That is also a great question. So perhaps Señorita Divide over the long term is generally a wetter site, and right now it's looking kind of dry. Perhaps there's an error in the measurement there. What's confusing is that you can't see the Pajarito Peak site hidden under that. So it would be interesting to compare that to the third site that's also in the similar vicinity and see which one matches better. But I would imagine that the Senorita Divide, they're also at quite different elevations. So it could be the case that snow has fallen high in the mountains and stuck around, and lower in the mountains, just even a few thousand or a few hundred feet lower, that may have already melted off and not be recorded right now. So we're only measuring snow water equivalent that is currently sitting at the site. That's not a cumulative measurement, unlike our precipitation. So what I do know, which is not shown on this map, is that Senorita Divide is a pretty low elevation site. So I would imagine that that has something to do with it as well. Great questions. Okay, so I've shown you kind of where these sites are located. Now the question is, what do we measure? A whole bunch of instruments on this one. This is more than a standard SNOTEL site. So to be a standard SNOTEL site, we only have a few variables that we measure at every single station. We're trying to add some instruments into the network. So this is at Cherie, which is in northern New Mexico, up the Rio Costilla drainage above Taos. And this is a pretty new site. We decided to instrument it with a bunch of auxiliary sensors as well to provide more data. But there are some key variables that we measure here. So I'll kind of go through them. It looks like a weather vane. Basically it is. So there's a propeller on there. It measures wind speed and direction. So that's an anemometer. This one with the yellow circle, that's our acoustic snow depth sensor, and I'll get into these a little bit more as well. This is kind of the bread and butter of what I do as a field technician, is install, maintain, and repair these sensors at these sites throughout the network. So that's pointed straight down at another part of our system here, which I'll explain in a minute. This one is a taller radiation shield. Looks a lot like the one on the left. That is relative humidity, so it's measuring the moisture in the air. This one on the left is our temperature sensor, so just air temperature in degrees Fahrenheit. This one up here, oftentimes we have it paired with another one, which would be at the bottom of this arm facing downward. That is a pyranometer, so it's actually measuring incoming solar radiation. The reason why we often have one facing down is we can get a net solar radiation measurement if we have reflected radiation coming off the surface of the Earth compared to the incoming radiation on the top of the sensor. So this big rocket-looking device, we do call these rocket precipitation gauges. I'll get into this a little bit more as well, because this is one of our key components. So snow depth, air temperature, cumulative precipitation, and then this one, this is the key to our snow telemetry network. This is what's most unique about the NRCS Snow Survey automated weather station network compared to other weather stations from USGS or the National Weather Service and other entities. This is a snow water equivalent pillow. So it's actually like a waterbed that I'll explain the function of later, but as snow accumulates on that, we can get a measurement of the accumulated water content of the snow by weighing it. And then this is sort of a trick. There's actually nothing buried right at this location, but in some of our stations and an increasing number of our stations, we actually bury soil moisture probes at different depths throughout the soil profile to measure temperature and water content in the soil. So as I mentioned, all of our SNOTEL sites are going to measure certain key variables. So snow water equivalent is the big one that we provide that's unique and very important to our water users. So that's the amount of water in tenths of inches contained in the snowpack. Snow depth, which is just simply the depth of the snow. Precipitation, which is the total cumulative amount of precipitation in tenths of inches that falls in the form of rain and snow at a site. Air temperature, simply measured in degrees Fahrenheit by a thermistor. And then some of our enhanced sites also measure, like I said, soil water content, soil temperature, relative humidity, wind speed and direction. I think more and more we're including that as one of our basic measurements as well, but it's not one of our 4 key components at a SNOTEL site minimum. And then solar radiation would be an auxiliary measurement as well. These generally report hourly to a accommodate the needs of any of our data users, such as avalanche centers, the National Weather Service, state agencies, disaster and emergency services during flood forecasting, and other climate and weather monitoring entities. So the anatomy of a snow site, as I mentioned, we have this shelter generally, which contains our batteries and a data logger and all of the wiring and interface. These antiquated antennas that we're actually getting rid of. It's all powered by solar. We measure the precipitation in our rocket gauge. We have the snow depth sensor facing down at the snow pillow. Some ground truth markers for when the snow does accumulate, so we actually know where the pillow is when we're walking around on 3 to 6 feet of snow in some places in high elevations, especially in Colorado or northern New Mexico. Our air temp. So this is a pretty basic station with an old piece of equipment that we don't deploy anymore for our telemetry. So the snow pillow, as I mentioned, is a unique component of our systems. So we have these water beds essentially filled with antifreeze, propylene glycol, ethanol. So as snow accumulates, it presses down on that pillow, and that is plumbed into the station, and we have a pressure transducer that is actually what reads the measurement there. So we're actually weighing the amount of pressure that's pushing down on that pillow and comparing that to the depth, which is facing right down on the top of that pillow. And that's how we come up with a snow water equivalent value that's continuously measured and then reported every hour. So then snow depth, this is just an acoustic sensor. So it sends out sound waves and they bounce off the surface of the snow and they return back up to the sensor. It measures how long that process takes and compares it to the bare ground or the top of the snow pillow. And that's how we get depth. And then we do go out and ground truth those with our measurements occasionally so we can tell if the instrument is calibrated or not. So among the standard sensors, as well as the precipitation accumulation gauge, this is essentially measured the same way. So the fluid builds up in that rocket gauge, and then we measure the pressure inside the shelter with a transducer. A unique thing about these is that, as you'll see on here, it's kind of hard to see in this photo, but there's sort of a shield around it, a whole bunch of kind of moving parts like a crown around the top of that gauge. Reason for that is that frozen precipitation in the form of snow gets carried by wind eddies and doesn't like to make its way into that orifice and actually fill the gauge. And we're trying to measure both rain and snow. So with the shield being a little bit higher than the opening, it slows down the wind and creates a calm space for snow to just fall directly down. So we think that this helps with actually capturing all of the snow that occurs. That's the shield. And then we do have to prime this with a little bit of antifreeze so that we can measure the frozen and liquid precipitation. So every year we have to clean that and recharge it with new propylene glycol ethanol to actually capture that frozen precipitation inside the rocket gauge. And then, as I mentioned, temperature. So we use these radiation shields because dark objects like the sensor itself will get an artificial reading of temperature from sun actually directly hitting that sensor. So we use a white guild shield to try and just capture the temperature of the air, not the heating from the sun coming in. Other sensors, as I mentioned, so we'll dig a pit and put in these soil moisture probes. So we do 2 inches, 4 inches, 8 inches, 20 inches, and 40 inches below the soil surface. So we can actually measure how fast water is percolating down into the soil profile. And we can get an estimate of how much water is actually being stored in the soil as well. And then, as I showed earlier, we've got all these auxiliary sensors on our station here. So then what about lower elevation? So we have this complex snow pillow and all this plumbing and everything in the high altitude because we're really concerned about measuring every bit of snow that falls in these given locations for our forecast. As you can imagine, we don't get a whole lot of snow or a whole lot of rain at this site. And this is a Silvietta National Wildlife Refuge south of Los Lunas, kind of in the Socorro area. So you can see this is kind of a pared down station. This is the entire weather station. The thing at the top is not a sensor. That's actually static electricity reducer to help this site not get struck by lightning. And then it just has wind speed and direction, has air temperature, solar radiation on these ones, and it has a rain gauge and then some soil moisture probes. So as you can see, much smaller of a footprint than the SNOTEL sites in the high elevation. But it helps to have that elevation profile. We can get better forecasts if we're measuring low in the valley bottoms as well as high up in the mountains. So I'll get in just a little bit into how we transmit the data out from these stations, but it wouldn't be SNOTEL without the telemetry part. So we measure some things, we store them on a data logger, and we transmit them out. And then they magically go to everyone's computer via the internet, which is pretty fantastic. This is the old way that we used to do it. This is World War II technologies, radio waves, even predates that in some cases. We're replacing this throughout the entire system. It's very power intensive. But here in New Mexico, we actually have quite a few stations that still run on this telemetry system. So it's called meteor burst, and that's those big antennas I showed on some of these sites. So it actually bounces a radio wave off the surface of the Earth, and it reflects up into the stratosphere, I suppose, up high in the atmosphere, where we have some ionized particles from meteorites and things floating around up there. The radio waves actually travel along those ionized trails and then bounce back down to a master station. We have two of these master stations in the western US. One is in Boise, Idaho area, and one is in Salt Lake City. This is incredibly power intensive. It's kind of unreliable, but it works really well here in the desert Southwest with clear open skies and a lot of kind of space junk floating around in the high atmosphere. So it's been deployed widely over the years, but we're replacing it with good old cellular and satellite telemetry. The problem, of course, in a place like New Mexico is we have these big open skies, but we don't have a lot of LTE coverage. So we're trying to find a good medium. This technology is set to sunset at the middle of next summer, so we've got some work ahead of us to replace this. So just a breakdown of how that works. We have a variety of satellite systems that we use, so geostationary satellites and low Earth orbiting satellites. That's kind of the wave of the future in places where we don't have good cell coverage, but we do need LTE. We were on 3G for a long time, and that's going away. So cellular stations we do use quite extensively, and then we're sunsetting this meteor burst technology on the bottom. And all the different data collection offices throughout our system. You can see here the Colorado Data Collection Office, including New Mexico, had the largest portion of this old meteor burst technology. So this was at the beginning of the summer, and we did a lot of work to transition those over to satellite or cell, and we're making good progress there. So who uses our data? Variety of users will tap into our resources. We hope that a lot of people, including maybe you yourselves, will find this data useful, but many of our other federal agency partners will rely on our data. So USGS for stream flow and flood forecasting, the Forest Service for fire weather and other conditions, National Weather Service for some of their forecasts and their river forecasts, the National Oceanic and Atmospheric Administration, several other agencies as well. Here in New Mexico, I know that the New Mexico Department of Environment and the Office of the State Engineer use our data quite extensively. Our state drought committees are big on our weather data for alpine climate or subalpine climate in the mountains, as well as the Soil Climate Analysis Network in the lower elevations. A variety of university researchers, avalanche centers, and like I said, the farmers and producers are our primary customers. I'm not going to get too far into this. We're getting toward the end here, so I'd like to get more into the current conditions and local, but this will be available on the recording, and I'll have my contact information at the end of the slideshow, so if anyone would like to see these slides, I can share these. But we do a great deal of data quality assurance and quality control before we release these numbers. So our hydrologists in Denver do the data editing for the data collected within our region. And then we do several iterations of that, as well as some automated data trapping. So there are a variety of websites that I would recommend if you're interested in following up on this. Those will be posted in the chat. These are our best resources for kind of public interaction with our data. And I like the maps. So this second link here, the iMap, pretty much everything that I'm going to explain coming up will be available on this interactive map. So you can find information about our program, our water supply products, the climate, contact information for the individual hydrologists and technicians within the program, and the various offices throughout the Western US. Within the National Water and Climate Center homepage, there are a variety of products available. One of those is the report generator. So what I did here with this one is just showing the Camazon SNOTEL site, which is the snow water equivalent for that site is in the blue at the bottom, just between 0 and 1 inches of water content there, compared to the Santa Fe snow water equivalent, which is this black line, a little bit above 1 inch. So that's higher elevation on the other side of the valley in the Sangre de Cristo Mountains. And then precipitation for Santa Fe in the gray, sort of gray-green here, and then precipitation accumulation for Camazon, which is actually a little bit higher than Santa Fe. So these charts, you can create kind of custom reports and charts on our website. We have these interactive charts, which I think are really useful. So on the interactive map, if you were to click on the Camazon site, you could get all of our metadata, parameters that we measure, and then these interactive charts. Here's kind of an example of how you can select the elements that you're interested in, the parameters that you'd like to see. And then you can, I am very visual in the kind of graphic and geospatial sort of way. So I like to create maps showing some of these things. So again, with the shaded coloring of, like, for instance, on this one, all I did was select all of our weather stations that are above 9,000 feet in New Mexico, and then snow water equivalent for compared to the percent of our long-term average, and that shows in these various different colors. So you could select for a variety of different factors here and create a custom map. We have all kinds of different reports and charts that you can create there. That's based off of the report generator on the website. And then, as I mentioned, every month I will publish this water supply outlook report. So those can be sent out via email, and my contact information will be at the end here. I'm actually the author of those for New Mexico, and I'm basically summarizing the work of our forecasters in the they're in Portland in the Water and Climate Center, and then they're using the data that we collect on the ground here in New Mexico. A variety of other products that are available on our website. I really encourage you to explore those. And then, as I was mentioning, the interactive charts. So you can scroll along these charts and get a value for each day along the chart. So this one is showing in the black line today's date, the 8th. Black is our snow water equivalent accumulation, and the green line is the median value. So we're well below median for today compared to the long-term median for this day of the year. The blue line would be the maximum ever seen at the site, and the red line would be the minimum. So these interactive charts are very informative, a lot to unpack here. We can also use them as projection plots. And then all of these products sort of culminate with our water supply forecasting, which is issued on beginning of each month out of the Portland office. So one thing to note, as we move through time, we use different reference periods for our statistics. So we did just transition fully into a new decade. So now our reference period is 1991 to 2020. Previously, our reference period of reference included the 1980s, which was a much wetter decade. So sometimes our current conditions look a little higher as compared to the long term because these last 20 years have actually been drier than normal, or these actually the last 30 years. So forecast points in New Mexico, I've kind of mentioned these. We create forecasts for various different drainages and basins throughout the state, and those will be detailed in the Basin Outlook report. The forecasts are based on very complex mathematics done by much smarter scientists than myself. So I'll leave this slide just for a brief moment, but we do use principal components multiple regression analysis for that. And we issue our official monthly forecasts based on that. As well, on our website, you can find unofficial daily water supply guidance forecasts, and our verification parameters are on the interactive map as well. So for current conditions here, so snow water equivalent, generally red is not great. So here in the Rio Chama Upper Rio Grande Basin for snow water equivalent, at this point in time, based on all the stations in that drainage area, we're at 62% of the long-term median, 1991 to 2020. Over in the San Juan Basin, they've gotten more snow and they've got more water in that snowpack, so it's a higher percent of the median. Lower down in these basins, we're looking poorer, so less than 50% of the long-term median. However, snow water is only one part of the equation, so water year to date precipitation, we're actually at 100% of normal here in this area, and then looking pretty good in the southern part of the state as well. So that is based on the huge amount of rainfall we've had since October 1st. So we're well above average with terms of total precipitation, but less of that has come as snow than compared to the long term. So here's a zoom in on that. Good to see. So looking at our interactive chart, you can see we started off, our precipitation actually started off way higher than the median. And over time, we've kind of tapered off. In the last couple of months, we've gotten less rain and we've intersected with this median line. So we're right on 100% of the long-term median. And then this graphic with the snow water equivalent shows us how much of the water is held in snow. And again, that snow is like a reservoir, so it'll be held through the winter and slowly released throughout next spring. We like to see a lot of water in our snowpack, but we're well below that long-term median right now. And I've taken up enough of the time kind of hammering on with all these very text-intensive slides, so I'd like to open it up to questions and comments at this time. And please do feel free to contact me directly via email or either of the phone numbers here. I am a public service, an employee of the federal government, so my door is always open to questions and emails and things like that. And we've got a question here in the room. Yeah, the question is to go back a couple of charts. Let me know when I get to where you'd like. Mm-hmm. Okay, so the question is kind of these brown areas where there are no measurements being taken. So over here in the western part of New Mexico, this area is actually forecast in an Arizona basin, because that flows down to the Colorado River. So we aren't including, I kind of masked this for just forecasts that we produce within the state of New Mexico. Similarly, here in the middle, we, as the NRCS, do not produce a forecast for this area kind of on the eastern side of the Sandia Mountains. This is a closed basin. So any water that falls here may percolate into the groundwater, but it doesn't flow out into an actual river system. So we don't do a forecast in this closed basin. We do for the Pecos because that flows down in a larger river system, and we do in the Canadian River as well for the same reason. But over here in far eastern New Mexico as well, we just don't have any high alpine weather stations, so we don't produce forecasts for those far eastern parts of the state. So we basically produce these forecasts within a geographic area defined by where we actually have weather stations to contribute data to that. And since these are kind of representing the highest altitude inputs for the state of New Mexico. Hope that helps. Other questions?
Okay, we have a couple questions that came in online. One is about, well, a couple about your forecast report. First is how long does it go, and then or I guess how long does your report? Is it just monthly, and it's a forecast for that month?
Yeah, so they're kind of rolling forecasts. I'll go back to this slide. I skipped over pretty quickly here, but they're generally seasonal. So we do it on a multi-month basis. And at the beginning of each month, we'll project out for several months into the future. So the most accurate kind of summer runoff forecast is going to be the very last one. We sort of start with a general projection and narrow down as we know more and more information about what that snow and runoff is going to look like over time. I think I had that in here somewhere. But basically, yeah, they're multi-month forecasts. And was there another part to that question? I'm sorry.
Yeah, do they take into account weather predictions?
So generally what our product is tailored to is stream flow. So we take all of our weather inputs and we estimate and forecast a stream flow volume. And there is another slide in here somewhere that, so what we're trying to estimate is what an unimpaired or naturalized flow would look like for that river system. So if there weren't any dams or impediments within that watershed, and then this is just a volumetric forecast of water output. So these official forecasts aren't going to predict weather, although they could be used for something like a El Nino Southern Oscillation prediction. The National Weather Service may use our climate inputs to project what the climate may look like over the long term, but we produce only stream flow forecasts.
Okay, so a question about the pillow. I saw the tall grass near your pillow, and there must be curious animals around. Does that affect your SWE measurements?
That's a great question. We've actually had to do several repairs to these snow pillows, given that it's kind of a hypalon or vinyl sort of waterbed. And the best picture is actually here. You can kind of see this chain link fence that we have on top of that. So we have hardware cloth, like a fine wire mesh, right over top of the waterbed itself. I keep referring it to that way because I think that's the closest approximation you'll get. But it's a thick, almost like a rubber whitewater raft material filled with this antifreeze. And then we have the fine wire mesh and then chain link fence over top of that. So we've actually had problems, especially in Colorado, with bears being interested in what's in those pillows and digging around, rooting around, and damaging those. This year at this site, we actually had a rodent burrow up from underneath and damage the pillow. So occasionally we do see that. And it'll just look like in our data stream that we're losing snow water equivalent very quickly, which is a leak in the pillow, and we have to go and replace that. So we do what we can to protect them and armor them, and then we have to repair them if that doesn't hold up. Great question.
The other question was about those grasses. I think this is actually the photo where you could see it.
Yeah. We are trying to sort of approximate a natural environment. So we do try to pick fairly sheltered areas where we're not going to get huge snow drifts, but we will also try to keep the vegetation from encroaching into where our acoustic snow depth sensor may reflect off of that foliage instead of the surface. But grass is a normal thing, and we're trying to measure kind of the natural environment. So we'll allow some grass to accumulate. We don't go out and mow it regularly because most of the landscape that's collecting snow isn't mown. This area actually has cattle grazing in the area, so whatever effects they would have, that they can get right up against our site. We don't have a fence around this one, so that grass is just what's ever survived the cattle in the area.
Just one more question about the pillow. The why antifreeze?
So these are in high altitude or subalpine environments. It gets really cold out there. So if we're trying to measure pressure, and we do that by the plumbing going into a pressure transducer inside of the shelter. So we know the specific gravity of the fluid, and we can do our calculations that way. But if it were just plain water, it would freeze. And then we wouldn't be able to measure that in the cold of winter. So even under all the insulation of the snow on top of it, we need that fluid to be able to flow in and out of our sensor setup within the shelter.
Okay. Is there a snow depth that when I think they meant when your measurements don't work anymore? Is there a deepest snow situation?
Well, things that can happen would be like ice within the snowpack if we got some melting and bridging to the surrounding snow, and then it was to melt out underneath that ice layer. That's not going to be pressing directly on the pillow itself, so we can't measure a really accurate snow water equivalent if we don't have kind of continuous loose snow within that, which is another reason why we go out to these sites fairly periodically and do a ground truthing measurement, and we'll note those ice layers within. The snow depth, these are mounted at 200 inches above the surface. All these acoustic snow depth sensors that face down at the snow pillow itself, we set them at right at 200 inches. In most areas within New Mexico, 200 inches of snow hasn't ever been recorded, so we think we're safe on actually having the snow depth sensor sitting on the surface of the snow. However, we did see in one of these pictures rhyming. So if there's ice and snow built up right on the snow depth sensor itself, that sound signal is going to bounce right off of that rime on the surface of the sensor, and it's not going to be able to get an accurate measurement. But we would basically see that the snow depth is reading at 200 inches, which we know is probably not accurate, and we can go out there and clean it off. Great questions. Thanks a lot. And this is, as a field technician, all this type of work is really my bread and butter. You probably notice I'm a little fuzzier on the forecasting and the math on that, but questions about the system itself, that's kind of where my expertise lies.
Okay. Are you hauling a lot of equipment out to these sites, or is it all stored in the shed?
So we haul the manual snow depth and snow water equivalent measurement apparatus, the tubes that I showed, out to the sites and punch those through the snow. The only equipment we haul to the site is the actual sensors themselves. If any batteries go bad or solar panels get damaged. And then we haul out things that we're retiring, like this old antenna will be taken off the site and taken out. But we try to do all this work, like I said at the very beginning of the presentation, we do most of our work in the summertime when it's easier to access the sites and we're not going to disturb the snowpack around the site. So we try to let this just sit as it is with minimal disturbance throughout the winter, and we haul very little in and out. I haul a field tablet, food and water for the day, and my snow course measurement tools, either skis or snowshoes or something to keep me above the snow surface. Even if it's shallow enough snow that I could walk through it, I want to have some flotation to not pack down that snow too much and try to keep the area as representative as possible of the natural landscape.
Okay, and I think that's all the questions I had from viewers online. Anybody else in the room? I'll keep an eye on the chat as we're wrapping up here. I just wanted to say thanks again so much, Jaz, for sharing your expertise with us tonight. And thanks to everyone who joined us for tonight's talk. Please remember to look out on your email for that quick survey coming. If you're interested in attending other Peak programs, we do have a virtual astronomy talk tomorrow night. And Home Alone and Hot Chocolate is on Saturday here in the planetarium.
That one sounds like a lot more fun than climate.
That'll be a fun one for sure. All right. Thanks again, everyone, and have a good night.
Thank you.